Powermill 2019.2 now includes an improved collision avoidance algorithm that gives users greater confidence when creating collision-free 5-axis toolpaths. In previous versions, there were cases where collisions were detected, but Powermill couldn't find a suitable solution to avoid them. So the colliding segments ended up getting removed or highlighted as red, without a fix being found. Even though this issue was not compromising safety, as Powermill will still identify the colliding segments for which it couldn't find a solution, it was obviously not desirable to have to program these areas separately, or to have to manually edit the tool axis. The algorithm has now been improved based on customer feedback to find suitable solutions in more cases than it did before. Moreover, the functionality has been improved to calculate more stable toolpaths, as Z-axis rotations are now minimized. Let's now look at an example of this enhancement. As you can see on my screen, I have calculated a 3D offset toolpath inside the rest boundary. In the Tool Axis tab, I have chosen Automatic as the tool tilting method. If I now display the colliding segments on my toolpath, we can see that Powermill has found a suitable tilting solution throughout my strategy, and no collisions were found. Switching to Powermill 2019.1 for a second, we can see that, in this version, there were a few collisions that the automatic algorithm couldn't avoid, with some areas still displayed in red on my screen. Going back to Powermill 2019.2, we can zoom in on the same area and notice that those segments are not displayed as collisions anymore. This will result in less programming time and fewer toolpaths being needed to fully machine the part, meaning more of the part can be cut in one go, which will in turn reduce the risk of defects appearing on the surface from multiple overlapping toolpaths. Let's now look at the improvement made to the stability of machine motion when avoiding collisions. Once again, on the left-hand side of my screen, I'm simulating a toolpath in 2019.0, while on the right-hand side of my screen, I have the same toolpath being simulated in Powermill 2019.2. It is clear how the machine movement is smoother and much less erratic with the new algorithm. This will result in a much better surface finish on my part, as well as reducing machining time, as the machine is able to maintain the program feed rate more easily. This improvement to the automatic collision avoidance algorithm in Powermill 2019.2 allows users to calculate safer and smoother toolpaths that can produce better machine parts faster, while also reducing overall programming time and effort.